With the blockchain, there comes a lot of technologies that can revolutionize how we use the internet. But in order to develop these revolutionary technologies, you have to learn the basics. Today, we're going to be going over a Buy Me a Coffee contract written in Solidity and deployed to the EVM blockchain. My name's Anthony with the Blockchain Dojo, where we teach you how to become a blockchain ninja and a Solidity expert. If you like what you watch and you learn something new, please like and subscribe for more content. Let's get started. The Buy Me a Coffee contract, we're going to be going over a few key concepts. First of all, we're going to be going over variables as well as immutable variables, mappings, as well as events, constructors, and functions. First thing we do in any Solidity contract is we declare the license identifier as well as the pragma version. Next, we declare the contract and we declare it Buy Me a Coffee ETH. This is just what I named it, as it's an arbitrary name just describing what the contract does. First, what we did is we declared a public variable storing the owner's address, as well as another uint public variable for the number of coffees purchased, and then an immutable variable for the coffee price. Next, what we do is we create a mapping of users' addresses to uint, and this is a private mapping which is tracking how many coffees an individual user has purchased. Next, we have our coffee purchased event, which has an indexed purchaser so that we can search via the purchasing address, as well as the number of coffees that have been purchased. Up next, we have our constructor function, which takes in a uint256 variable for coffee price, and then it does two things. First, it sets the owner as the message.sender, which is the deployer of the contract. And then it sets the immutable variable up here, coffee price, to the passed in coffee price value. This Buy Me a Coffee function allows users to pass in the number of coffees they want to purchase for the user and then send in the appropriate amount of ether. This payable keyword is what allows this function to be able to receive ether. Next, that we require that the message.value is going to be greater than or equal to the number of coffees times the coffee price. Essentially, what we want to do is we want to make sure that the ether being sent in this message is going to be equal to the number of coffees they want to purchase times this immutable coffee price. Then we increment the number of coffees by the number of coffees passed in, and then we track the mapping of the user's coffees to the message.sender plus equals the number of coffees purchased. Now, we use this plus equals operator as we don't want to rewrite how many coffees a user has purchased, but we want to increment and increase the number. After that, we emit a coffee purchased event, passing in the message.sender and the number of coffees purchased. Up next, we have a withdrawal function, which requires that the message.sender is equal to the owner, and then makes a call to the owner's address, sending out the value of this contract's balance. And then we require that the transfer is successful. Finally, we have an internal helper function to calculate the number of coffees per user, where we pass in a user's address. We go into the mapping and then we multiply the number of coffees purchased times the coffee price to determine how much total ETH a single user has passed in. And then we have a public facing version of that function to get the user's totals, which is again getting the total amount of ether sent from any individual user. As you can see, that contract is pretty straightforward, where it really is ultimately just sending an ether to a contract, keeping track of the variables or the amount of coffees per user and in total, allowing the owner of the contract to withdraw from the contract. Up next, though, what we want to do is ensure that each function returns the appropriate output. So we're going to be testing the contract. Let's get started. So in order to test this contract, the first thing that we want to do is we want to import the expect keyword from the chai library, as well as the Hardhat runtime environment from Hardhat. Next, I create a function. I'm not sure if I even use this function, but I create it in almost all of my tests just to use just in case, which takes in a variable number and passes it to the string for ether and parses the units with 18 zeros at the end. Next, what I do is I wrote a describe block to describe the buy me a coffee ETH contract, declaring the coffee contract deployer and user one. With the Mocha testing framework, it gives us the ability to run a set piece of code before each one of our describe or it blocks. So what we do is with this before each, we assign the deployer and user one to the get signers array. We then declare the coffee contract by deploying the contract. And then next we await for the deployment. In the following describe block, what we do is we describe the deployment in the constructor to ensure that when the contract's deployed, all the appropriate variables are set. So within this, I check that the deployer is the owner by doing expect await coffee contract.owner .to equal deployer.address. Checks that the number of coffees is initialized to 0. Again, expect await coffee contract.coffees .to equals 0. And then we check that the coffee price is initialized to 1. So we do expect await coffee contract.coffee price.to equal 1. And that 1 is declared here where we pass it into the constructor. In the following describe block, what we do is the buy function where we test the buy me a coffee function. So we create another before each to run before each of these following tests, where we assign the transaction to the await coffee contract.connect user one to buy me a coffee one also sending in one way, which was the cost of the coffee described within this deployment section. Next, we want to check the success describe block, where we want to check that the balance of the funds are sent. So expect HRE Ether's provider get balance coffee contract .to equal 1, where we check the balance of Ether within the coffee contract to equal one way, which is where which it received that one way from this contract call, passing in one way, buying one coffee. Next, we want to check that the number of coffees have increased. So we want to make sure that the coffee variable is equal to 1 since one coffee was purchased. Then we want to check that the user mapping is equal to 1, meaning that the user mapping from user 1 is tracked properly to the one coffee purchased. Following, we want to check that the event was emitted, which you can see here, coffee contract connect user 1, buy me a coffee, to emit coffee purchased with the arguments of user 1's address and then one coffee purchased. And then, of course, with every test, we always want to check for the failure. So in the describe block, we want to check to make sure that the call was reverted because not enough Ether was sent. Next, we have our withdraw function. This is testing that the deployer is able to withdraw funds from the contract. So again, we do a before each to run before all the remainder tests, where we get the initial balance, we run the transaction, and then we connect to the deployer and withdraw the contract. Now, this describe block is going to be a little tricky, so I want to go into a little bit more depth with this. In order to describe the success, and we actually need to test that the balances have withdrawn, we need to get a few variables. So first, what we need is the gas used. So this is going to be the total amount of gas used. And then we need to get the gas price. So that is the cost of the price of the gas. Next, we get the total gas, which is going to be the gas price times the gas used. Then we want to declare the ending balance, which is going to be what the balance of the deployer's address is after calling the withdraw function. And then we need the expected ending balance. And the expected ending balance is going to be the initial balance minus the total gas spent to call the withdraw function, plus the one way that is within the Ether's contract, within the buy me a coffee contract. And then finally, what we want to do is we want to expect that the ending balance, which is going to be the balance of the deployer's wallet, is going to be equal to the expected ending balance, which is the initial balance, which we declared right here, minus the total gas spent, which is the gas price times the gas used, plus one way. Following that, we also want to ensure that the contract balance is set to 0 after the Ether is withdrawn. And then, of course, like I mentioned, we always want to check for the failure case, where we'll be running a before each, checking that the coffee contract connects to user 1, not the deployer, to buy a coffee. And then we try to connect back to user 1 to withdraw the coffee money purchased, even though the user one is not the deployer, which will ultimately revert. Next, what we want to do is we want to run the tests. So we do npx hard hat test. And just like that, you can see all the tests that passed, the deployment constructor, the buy function with the success and failure cases, and then the withdrawal function with the success and failure cases. Buy me a coffee contract is a pretty simple concept to understand, as well as it's been implemented across the Web 2 and Web 3 space. In this video, you got to see how to implement your own version of the Buy Me a Coffee contract, as well as how to test it. Thanks for staying to the end. If you did learn something new, please like and subscribe for more content.